These are the step-by-step answers for the AP Calc BC Series Multiple Choice Problems Practice Quiz 1. So you are on question 1, and it's asking for what is the value of this series below. So what I can notice here is that I feel like ratio test applies best with this problem. If you guys don't remember your ratio test, it's going to be from limit to n is approaching infinity, your function with n plus 1 over a of n, and we're going to determine the value of this. So let's plug that in here. So limit as n is approaching infinity, that's going to be 3n plus 1 over 4 n plus 1 plus 1 over 3 of n over 4n plus 1. Now what I can quickly do here is simplify this. N plus 1 is just going to be n plus 2. And all we need to do here is reciprocate it. So let's clean that up. Then since we can't have fractions in the denominator, we are going to reciprocate that fraction so that we can just multiply it instead of make it into a long, complicated division problem. So it's going to be 4n plus 1 over 3n. So what we're going to do next is we're going to separate everything. Properties of logs say that 3ax plus y can be rewritten as 3x times 3y. So that's what we can apply here. So limit as n is approaching infinity is going to be 3n times 3 to the 1, 4 to the power of n times 4 squared, times 4n times 4 to the 1, and then 3n. So now what we're going to do here is do a cancel party. So we're going to cancel out like terms, 3 to the n over 3 to the n. What else is here? 4 to the n is also canceled. All we have is constants left, which is a really clean problem. So limit as n is approaching infinity, we're going to rewrite that. 3 to the power of 1 is just 3. 4 to the power of 1 is just 4. 3 times 4 over 4 squared, which is just 16. And then 3 times 4 is going to be 12 over 16, which that simplifies to 3/4. This concludes question number 1. Moving on to question number 2. The Maclaurin series for 1 over 1 minus x is this series. Find the power series expansion for x cubed over 1 plus x squared. So we're dealing with this here. These are one of your memorized series that you need to know for the AP exam. Let's write that out. 1 over 1 minus x is this. 1 plus x squared. I'm going to do it to the 5th degree. You don't have to, but I feel like that's more precise. 5th degree. Alright, and then since we're having a sign change here, I'm going to have to alternate this. So it's 1 over 1 plus x. So it's going to be 1 minus x plus x squared minus x cubed plus x to the power of 4 minus x to the power of 5. Okay, now we did that. Now we're going to square it because of this 2 right here. Let me circle that 2. We're going to square each of the x's. So it's going to be 1 over 1 plus x squared. So actually I'm going to change this into a different color so that it's more clear on how I'm transforming the series. I'm doing this little by little so that way it's not going to be too difficult on distinguishing how to derive and reassemble these series backwards. So let's say that 1 is just x to the 0, and since we're squaring it, all we need to do is just square it. So 0, x to the 0 squared is just going to be x to the 0, which is just 1. So we're going to leave that alone, minus negative x squared. Oh, I'm sorry, not negative. X to the 1 squared, which that's going to be, wait. Oh, it's gonna be x squared. Then x squared times x squared is going to be x to the 4th. Then this is going to be x cubed squared, which is just going to be negative x sixth. X to the 4th squared. Remember that the properties of exponents say that when a number is being multiplied to the exponent, you multiply the exponents and not add. The only time you add the exponents when you have something like this, that equals x of a and b. But this is not the scenario here, since you're multiplying exponents and not bases with like exponents with like bases. Okay, so there you go. X to the 4th. 4 squared. 4 times 2. X to the 4th. Wait, did I? Oh, no, I did it right. No, I didn't write it down yet. X to the 8th. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, one more term. X to the 5th squared. That's just going to give you x to the 10th. Okay, that's the transformation for the next one. Now the last part is, it's going to be x cubed over 1 plus x squared. So basically this can be rewritten as x cubed times 1 over 1 plus x squared. That's the same thing. So all we're going to do here is multiply everything by x cubed. This, everything. Now this is where you add the exponents instead of multiply them. So you should get, this is going to be a simple process. I should put this in green, but it's fine. It's going to be x cubed minus x to the 5th plus x to the 7th minus x to the 9th plus x to the 11th minus x to the 13th. And that is your final answer. This is the expansion of your series here. This concludes question number 2. I am moving on to the next set of 2 questions. Okay, moving on. Question number 3 and question number 4. So a function f has Maclaurin series given by 1 plus x over 2 factorial plus x squared over 3 factorial plus x cubed over 4 factorial, given this common ratio series here. Can we find an expression for f of x? So as you can see that we can you have to memorize, remember those memorized series. We have e to the x. Why is it not drawing? Zoom in. Okay. We have e to the x, sine of x, cosine of x, and the arctangent of x. So we can cancel this one out because this one, the 1 over 1 minus x series, does not have factorials. The series does not alternate, so it's not sine or cosine either. So that cancels out. And only e to the x has factorials and does not alternate. So this is going to be an e to the x function. Find an expression for f of x. So let's write the e to the x power series here. E to the x power series is going to look like 1 plus x squared. How far did they get? To the 4th degree. Plus x cubed over 3 factorial. Plus x 4th over 4 factorial. Okay. So what did they do to adjust everything here? What I feel like they did was, ooh, okay, I feel like to compare here, they divided by x. So if you divide by x, x squared divided by x is just x cubed divided by x is x squared, and x to the fourth divided by x gives you x cubed. So that's the comparison for that. So we're gonna do this. E to the x divided by x, which gives you 1 over x plus 1 plus x squared over x times 2 factorial plus x cubed over x times 3 factorial plus x to the power of 4 over x times 4 factorial. Now we can simplify this. So let's leave that 1 over x alone, plus 1. This multiply. So it's going to be x squared over 2. X squared, x cubed minus x is just going to be 2. So it's going to be, what did I do with that? Okay. Oh, why did I put a 2 there? Typo. Plus x squared over 3 factorial plus cancel that out. That's just going to give you 3 plus x3 over 4 factorial, then so on. Alright, now comparing this, we're not quite done yet. We still have a 1 over x here. So now what we're going to do is e to the x over x. Then we're going to subtract this and move it here. And if we look from here to here, this is the exact same thing. So our power expansion is finished. So our final answer is e to the x over x minus 1 over x. Or if you want to simplify, it's going to be e to the x minus 1 over x. I should circle that green. And that is your final answer for number 3. Number 4. What are all values of p for which the infinite series n cubed over n to the p plus 1 converges? So what we're going to do first, I could tell this is already a p series question, and since it converges, p must be greater than 1. I don't know why I changed the pen there. P is greater than 1. So let's rewrite this. We're not going to focus on this. That is not important for this problem. So it's n cubed over np plus 1. We can cancel out this 1. This one is insignificant. Why? So Mr. Rodriguez taught you this example. If you have a bank account, or if you have a lot of money with you, and let's say $1 million, and you add $1, does that make a big change in the amount of money you have? No. So that one is insignificant for this problem. So you are left with n cubed over n over p. Now you can rewrite that as 1 over np times n to the negative 3 based on properties of exponents that you learned in Algebra 2. Now, another property, if exponents with the same base are multiplied, they are added. So it's n over p minus 3. And now we need to find when when this series converges, and it converges at p is greater than 1. So you need to set this little guy here to greater than 1. Yes. So it's p minus 3 is greater than 1 plus 3, which gives you p is greater than 4 as your answer. This concludes question 3 to 4, going on to 5 and 6. Number 5 is asking for a divergent or a divergence in our series. So let's identify each series first before we get on with identifying what is what. So why is it not drawing? I don't know. Okay, there we go. So now we're gonna edit. So I can tell here that this is already a geometric sequence. Why? Because of the a of n here. A is gonna be our number here. So E is gonna be 2.718 approximately, and the sine function is bounded between -1 and 1. So it's gonna be -1 or 2.718 over 1. But since we're dealing with absolute value, it's always going to be positive. So your answer is going to be 2.718 to the power of n. But we're not quite done yet because we're checking for convergence or divergence. So when your r, or your 2.718 here, is less than 1, it converges. If your r is greater than 1, it diverges. So is our r less or greater than 1? It is greater than 1, so it diverges. Let's label that D here. Well, let's circle that as one of our options. This is a p-series problem because this can be rewritten as 1 over n to the 3/4. And let's say, and for p-series, as long as p is less than 1, it diverges. Or equal to, less than or equal to 1, it diverges. If p is greater than 1, it converges. So now we're going to study that. So is 3/4 less than or equal to 1, or is it greater than 1? 3/4 is less than 1, so this is also a divergent series. For this one, remember about adding $1 to your $1 million amount? That is insignificant. N squared over n squared is equal to 1. In a lot of series, especially this, this is this diverges. Even ratio test, it's indeterminate, but we're not using ratio test for this. So yeah, just make sure to study those series and the properties of those series. So this one diverges. Circle that. Let's check for this one. This one, I can't think of any other series that applies to this. It's not harmonic. I don't think so. I don't know if it's telescoping. The best test to use for convergence here is a ratio test. Remember that your ratio test is limit from n to infinity, a to the n plus 1 over a to the n. Let's apply that here. So limit as n is approaching infinity is going to be 1 over n plus 1 over 1 over n factorial. So why did I make that red? Okay. We're going to leave that, and we're going to reciprocate that because we cannot have fractions in the denominator, so we're going to reciprocate everything. Now, we got this as our answer, but we're not quite done yet. Why? We can simplify this factorial. Let's apply the limit of n is approaching infinity again. 1 over n plus 1 times n factorial. That's their properties of factorials. I would recommend reviewing that if you don't remember how to apply these, times n factorial. Those factorials cancel, which gives you limit as n is approaching infinity, 1 over n plus 1. Now we're going to plug in infinity there, which is just going to be, actually we already plugged in infinity, so we don't need to write that. 1 over infinity plus 1, which is just 1 over infinity, which is just 0. And according to ratio test, if your answer is less than 1, it converges. If it's equal to 1, it's indeterminate. And if it's greater than 1, it diverges. Since 0 is less than 1, it converges. And this does not diverge, so this is not one of our options. So options 1, 2, and 3 have a divergent series. This concludes question 5. We are on to question number 6. what is the coefficient of x squared in Taylor series for root 1 plus x about x equals 0? So I like to point this out. Whatever degree you have, that's the number of times you derive. So since we have x squared here, you're going to derive 2 times. If it was x to the third, you're going to derive 3 times. If it was x to the fourth, you would derive 4 times. Okay? So f of x is 1 plus x. Now we're going to derive that using memorized derivative. That's going to be 1 over 2 root 1 plus x. F double prime of x, this is our last derivative. It's going to be 1/2 times 1 plus x to the negative 1/2. We're going to use power rule. I don't know why there's a ruler there. I don't want this ruler here. Okay. That's going to be 1/2 times negative 1/2, 1 plus x, 1 negative 1/2 minus 1. That's going to be negative 1/4. 1 plus x, negative 1/2 minus 1 is negative root 3. I mean negative 3 over 2. Negative 1 over 4 times 1 over 1 plus x cubed. So you should get, to clean this up, you should get negative 1 over 4 root 1 plus x cubed. Let me just circle that for now so that we don't get lost with our derivatives later. And it's asking for what is the coefficient of x squared. To label Taylor series in terms of your second degree, that's going to be f to the second power, because you are having second degree, of 0, because it's going to be f to the second of x, which x equals 0, times your degree here, x is x squared, over 2 factorial, but that's just equal to 2, so we can just remove that factorial. So x squared, this is going to be equal to negative 1/4 times 2. Because of this, we're going to multiply that, root 1 plus x cubed. And I think we're going to leave that x squared alone. Oh, yeah. So we're going to focus on the coefficients in this problem. So it's going to be, I did not circle that, negative 1 over 4 times 2, which is just going to be negative 1 over 8, which is your final answer. This concludes question number 6. This concludes these 2 questions here. Moving on to questions 7 through 8. Two, 4, 6. Okay. All right. Question number 7. What is the approximation of the value of cosine of 2 obtained by using the 6th degree Taylor polynomial about x equals 0 for cosine of x? Okay. So these are one of your memorized what do you call these? Series. So cosine of x is gonna be, since cosine of x is, I feel like that belongs to the evens side. I always think of it as that way. So it's gonna be 0, 2, 4, 6, and so on. And it also alternates. But when you alternate, it always subtracts first, then adds, and then alternates throughout. So it's gonna be 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial. Cosine of x is done. Now we need to do cosine of 2. So basically, replace all your x values with 2. 2, 2, 2. That's basically what it's telling you. So it's going to be 1 minus 4 over 2 factorial. We can just subtract that and we can turn it into a 2. 2 to the 4th is 16. So it's going to be plus 16. 4 factorial is going to be 24. Minus 2 to the 6th power is 64. 6 factorial is going to be 720. And now it's asking for the approximation of this using the fifth degree. So now we already finished the expansion. So now we're going to simplify everything. 1 minus 2 is just going to be negative 1 plus 16 over 24 minus 64 over 720. 64 over 720, well, we can simplify that and divide both sides by 16, which gives you negative 1 plus 16 over 24 minus 4 over 45. And this can be simplified over here. So we divide both sides by 8. So it's going to be negative 1 plus 2 thirds minus 4 over 45. Now I'm going to do that. I'm going to simplify everything. So I'm going to multiply this by 15 and then multiply this by 45 over 45. So you get negative 45 over 45 plus 30 over 45 minus 4 over 45. That's just going to be negative 45 minus 4 is negative 49 over 45 plus 30 over 45. Since these have a common denominator, all we need to do is combine that negative 49 and positive 30, which gives you negative 19 over 45, which is your final answer. This concludes question 7. Moving on to question number 8. So, which of the following series converge? So looking here, this is a geometric series since we're dealing with two constants. E is 2.718 and pi is 3.14. This is going to be less than 1, so this is going to be a convergent. So is this one of our answers? Yes. Looking at this is an alternating series problem. Why? It's because this sine function here is a switcher. Sine, cosine, or negative 1 to the n is a switcher. If it was negative 1 to the 2n, it was not a switch. It's not really a switcher, because if you multiply any number by an even number, it's always going to give you even, which negative 1 to the power of an even just gives you positive 1, so it doesn't affect your problem at all. Alright, so this is an alternating series problem. Why did I undo that? This is convergent. Let's ignore this since this is a switcher. We're left with 1 over root n. So we're going to use the alternating series test. Is your function positive? Do you see any negatives here? No. So yes, this function is positive. Is when the limit is approaching infinity, does this approach 0? Yes, because as your n gets bigger, since the denominator is greater than the numerator, that means your numerical value result is going to be closer to 0 the more you increase the value of the denominator. So yes, this is true. Is a of n greater than a n plus 1? So is 1 over n greater than 1 over root n plus 1? Yes. Why? We literally just explained that. The bigger the number, or the bigger the denominator with the small numerator, the bigger it gets, the more smaller the outcome gets. So yes, this is true. So yes, this series does converge because of alternating series test. Alright? Alright, so this 75 over n ratio test. You just need to distinguish, when should I use alternating series test? When you see switchers here, negative 1 over to the power of n, sine times whatever power, and cosine, and then when you use integral test, when you see p series, so it's going to be 1 over n to the p equals whatever value. It could be 1/2, it could be any other value. It doesn't necessarily restrict it to that, but that is the most applicable test to save time on the AP test. Alright, so we're going to do this. Remember that your ratio test formula looks something like this. Like that. So we're going to apply that here. limit as n is approaching infinity is 75 over n plus 1 over 75 over n. Then we're going to simplify that and do 75 over n plus 1 times the reciprocal, because we cannot have fractions in the denominator. We canceled out those 75's, which gives us limit of n is approaching infinity, n over n plus 1. If we plug in infinity, that's going to be limit as n is approaching infinity. Actually, you don't need to plug in infinity anymore. Is going to be infinity over infinity, but since we're bounded between these absolute values, that's going to equal 1, which in this case, 1 is indeterminate, so this does not converge nor diverge. So only series 1 and series 2 converge in this problem. This concludes question 8. This concludes this page. We are moving on to questions 9 and 10. 2, 4, 6, 8, 10. Okay. All right. 9 and 10. For what integers of k, which k is greater than 1, will both these series diverge? All right. So we already have a hint here. K is greater than 1. And looking at these series, which one would be more easier to solve when it's going to diverge? It's going to be this one. Switcher alternating series test sounds a little bit complicated for this problem here. So we're going to use the second problem, or the second series first. So we're going to find the divergence. So we're going to use ratio test for this. Okay? Limit as n is approaching infinity. I'm not going to rewrite the formula. We just did it. 5 over k times n. I'm gonna do the split work already. Actually, no, I'm gonna make it look like that. N plus 1 over 5 over k n. Now this can be simplified as 5 over k n times 5 over k over 5 over k n. These two cancel out. We are left with 5 over k. And then to test for divergence, remember in ratio test, a series diverges when it's greater than 1. So we're going to multiply this by its inverse or reciprocal, which is going to be k over 5 times k over 5. 1 is greater than k over 5, so times 5 times 5. 5 is greater than k, meaning k is less than 5. So we already got our intel for this problem. K is greater than 1 and k is less than 5. So your answers could either be 2, 3, or 4. So what integers for this will diverge? We're going to move on to this switcher alternating problem. So we're going to test two things. Is k going to diverge when it's even or odd? So I wrote that messy. -1 times 2 to the n. So they're going to make k even. Remember that anytime you multiply a number by an even number, it's always going to give you an even number. And -1 to an even number is just going to give you 1. So will that make it diverge? Yes. 1 over n, diverge. Why? This is a harmonic series. This diverges. Now let's go to k is odd. Let me circle that this is even. -1 to the n. Alright, so whenever a number is odd, remember that -1 to the 1 is going to be -1, -1 to the 3, -1 to the 5, 7, 9, 11, and so on. that's going to give you a negative number. So it's going to be negative 1 of n over, is that n? Yes. So that's going to make it converge because this is an alternating harmonic. So it's going to make it converge. So when your k is even, and when your k is greater than 1 and less than 5, that's when it diverges. So it's going to be 2 and 4 is your divergence points. Okay, this concludes question 9. Moving on to question number 10. What is the approximation for the value of e cubed obtained by using fourth degree Taylor polynomial about x equals 0 for e to the x? Memorize this function, this expansion. It's going to be 1 plus x squared over 2 factorial. Since it's only asking for fourth degree polynomial, we are only going to do x to the fourth over 4 factorial. Now it's going to ask for e cubed. So we're going to replace all of those x values with 3. 3, 3, 3, 3. Now, I assume that you guys know how to do your algebra, so I'm going to go straight to it. You are going to get 1 plus 3 plus 108 over 24 plus 108 over 24 plus 81 over 24. That's simplified. That's going to be 4 plus 108 over 24 plus 108 over 24 plus 81 over 24, which that equals to 96 over 24 plus 108 times 2 over 24 plus 81 over 24. Simplify that, that's just going to be 393 over 24. I hope you don't have to simplify this for a test, but Mr. Rodriguez put this as a mixed number. I calculated both numbers and they gave me the same answer, so it should be right. It should be right. This concludes question 9 and 10. We are moving on to question number 11. Here we go. 11. 2, 4, 6, 8, 10, 11. Okay. Alright. Question 11 out of 19. Why is it moving? Okay. 7, 8, 9, 10, 11. Okay. Let f be a function given by f of x, ln of x minus 2. The third degree Taylor polynomial for f about x equals 3 is. Derive this 3 times because this is asking for the third degree. F of x equals ln of x minus 2. F prime of x equals, you guys should notice these are your memorized power rule derivatives, chain rule, etc. I'm just gonna give you the derivatives. Alright. If you do need help having to derive each of these functions, just let me know and I'll help you out with that. So now we're gonna plug in the third degree. So we're gonna use this and we're gonna plug in x equals 3 to that. So f triple derivative of 3 is equal to 2 over 3 minus 2 cubed, which is just going to be 3 minus 2 is 1 cubed. It's just 2 minus 1, which gives you 2 as your answer. Okay, this concludes question number 11. Moving on to question number 12 and 13. All right. Okay, what the heck? Let me expand this picture. Why can I not write on this? Okay. Oh, there you go. There you go. Alright, the graph of the function represented by the Maclaurin series 1 minus x squared plus x fourth minus x to the 6 intersects the graph of y equals x cubed at x equals. So since there's no factorials, we can automatically assume that this is a 1 over 1 minus x series expansion, which is going to be, since there's 4 terms here, I'm going to do the first 4 terms. 1 plus x, why is it not writing? Plus x squared plus x cubed. Why is it moving? Okay. Alright. Plus. Okay, now it's drawing. Okay. Plus x cubed. Alright. So what do I notice here? It alternates, meaning that there's a plus sign that has been changed. 1 plus x. 1 minus x plus x squared minus, why is it selecting that? How do I lock this? I can't lock it? Okay, forget about it. Okay, now it's drawing. Plus x. No. Minus. Minus x cubed. There you go. And then now, for some reason, it's gonna be, we're not multiplying by x squared. Why? Because this would have been an x squared if you multiplied it. It's supposed to look like a 3. That looks very messy. My bad. 1 over 1 plus x squared. Okay. We're gonna this is basically, let me change the color. Squared. X to the 0 squared. When that multiplies, that's gonna still be x to the 0, which is 1. X to the 1 squared is just gonna be negative x to the 2 plus, let me change this. What is wrong with this page? Okay. That's just going to be x to the 4th, and then x to the 3 squared. That's going to be x to the 6th. Alright. And does that match? Yes, it matches that. But we're not done yet. 1 over 1 plus x squared, this expansion intersects y equals x to the power of 3. So, there's a little trick that I'm going to show you guys. It involves your TI, since the graphing calculator for this section is allowed. So we're going to graph 1 over 1 plus x squared as your y1 and then your y2. Now click math, and then click math, go to solver. I learned this trick in AP Chem, which saves so much time. And then make sure that these two are subtracted from each other. So 3, let's arrow that there. And then your x, we're gonna make that as, let's see if x works when it's equal to 1. No, it doesn't. Let's make your x value very small. So it's x equals point, I don't know. However, just make it, why is it doing this again? Okay, now it works. X is equal to point, why is it doing this? X equals point 0.0001. I'm gonna draw with this pen. This point, oh, it also moves with this. Why does it do that? Okay. Point. let's say that there's a 0.0001, 0.000001. Then you're going to click alpha. That's a 5. Alpha trace. And you should have gotten 0.838. I don't think I put enough ones. And this should have given me, yeah, 0.838. Unless, was it the other way around? Oh yeah, it was the other way around. Okay, I plugged it in wrong. Yeah, so it's gonna be 1 over 1 plus x squared minus x cubed when you put your function. So you do the alpha trace for those when you use your solver. Then you subtract them together, and then you put it at x equals a very, 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 very small number. So that way it gives you the most precise number since your value is very low. So you should have gotten your answer as point, oh my gosh, 0.838. I cannot write dots anymore because this picture will move. Okay. Number 13. If limit b is approaching infinity, dx over x to p is infinite, then which of the following must be true? Well, since b is approaching infinity, we can technically rewrite this as 1 to infinity, 1 over x to the p dx. Yes? And remember that if it's infinite, it diverges because it goes to an infinite ton of numbers. So it's either going to be B or E. Well, we never got into, I don't even know why this is an option, because B is the B is the obvious answer here. All right. Let's continue and go to question number 14. 13, 14. Is it this one? Oh, great. Can I not move it to the next page? No next page? Okay. Let's make it large. Alright. Alright. Perfect. I don't know if I can zoom in here. That's fine. Alright, the Taylor series for the natural log centered at x equals 1 is this series. Let an f be the function given by the sum of the first four non-zero terms of this series. The maximum value of ln of x minus f of x for 0.8 to 2.5 is. Okay, so we're going to try to find this in terms of your, why is it moving? 4th degree. Oh my gosh. 4th degree. Alright. So there's going to be x minus 1 to the 1 over 1. We're not going to add that. I shouldn't put this as white colored because it's going to be hard to see. Minus. Why is it going to be minus? Because of this switcher here. It's only going to be negative when your n is positive, because 2 plus 1, or odd plus even, makes an odd, which gives you negative 1. So that activates the negative part of your switcher in the function. So minus x minus 1 squared over 2 plus x minus 1 to the third over 3 minus x minus 1 to the fourth over 4. Store this. Plug in that function and store it. Feel free to pause the video so that you can plug this in your calculator and store it as, let's put this as y2, because this is f of x. It's going to be y1 minus y2. Your y1 is going to be ln of x. So store those two and then come back when you are done. Alright, so now we're going to have to graph this function, y1 minus y2. Yes, so that's going to be stored as y of 3. Do not forget the absolute value function, otherwise you're going to get a funky answer. Alright? So now, after you plugged in, why did I not write y3? y3, we're gonna do this. So go back to your regular calculator mode, and then do alpha trace y3, and then multiply it by 0.8 and multiply it by 2.5. And remember that we're going to be looking for the maximum value, so we're going to look for the greatest number. So this answer is going to be 7.69 times oh my god, okay, times 10 to the negative 5. That is a very small number. I highly doubt that this is going to be the highest answer. This one is going to be 0.682, which is obviously bigger than this number. So yes, your greatest value is going to be 0.682 because we're looking for the greatest candidate, if you remember that from particle motion. Alright, why did it go back up? Moving on to question number 15. If this series is a Taylor series that converges to f of x for all real x, then f prime of 1. So we have a factorial here, and the only functions that have factorials are e to the x and your cosine and sine functions. The arctangent does not, so that is out of the picture. We are going to move on to this. So let's test each term. So let's start at x to the 0 over 0 factorial. X to the 0 is going to be 1, which oh my gosh, this picture is dumb. Okay, that's just going to be 1. We're going to look for the second degree. X to the 1 over 1 factorial. That's just going to be x. And x to the second over second factorial is just going to be x squared over 2. There's no switchers here, meaning this is going to be an e to the x because of this power expansion here. Alright, all I did here was plug in the first, first two terms here, just to give you a proof of which series this applies to. So this is an e to the x. We're going to look for the second derivative and evaluate that at 1. This is going to be really hard. What is the derivative of first derivative of e to the x? E to the x. What is the second derivative, or what is the derivative of the derivative? What is the derivative of e to the x? E to the x. Now we're going to evaluate that at 1. So e to the 1, e. That is your answer, C. Alright, this concludes question number 15. Moving on to the next page, 16 and 17. Alright. We're almost done. 2 more questions left. I don't know why that... Okay. What are all values of x for which this series converges? I can tell that we could definitely use alternating series, but we're trying to find values. Alternating series just proves that it either converges or diverges, so that does not apply. Integral test, I wouldn't use it here. This is a P series, but there's too much variables here. So best test, ratio test. Alright? Okay, perfect. I can edit this cleanly. Yeah, cleanly. Alright. Yeah. So we're gonna apply that ratio test. Let me activate the pen. Okay. Limit as n is approaching infinity, x minus 2. Why is it doing that? N plus 1 over n plus 1 times n plus 1 minus 1, which is just going to be n, times the reciprocal, which is just going to be n over n minus 1 over x minus 2 to the n. I'm going to simplify everything already so that I do not consume too much space, so it's going to be x minus 2 times n minus x times 2 times n and minus 1 and plus 1 n and x minus 2 to the n. Cross, let's do the cancel party. Yeah, this should be it. Yes. Alright. Let's clean up your leftovers here. We can factor out that x minus 2 because that does not correspond with your limit as n is approaching infinity. And that's going to be n minus 1 over n plus 1. Which that's just going to give us x minus 2 times infinity over infinity, but in absolute value, we're going to use this as 1. So we're going to use the ratio test. It's going to be x minus 2 is less than 1 and x minus 2 is greater than negative 1. Those are the two situations in which you should apply so that you can get your domain. Plus 2. X is less than 3. And let's add that. Plus 2. X is greater than 1. So I don't know why I highlighted that green. X is less than 3 and x is greater than 1. So your domain should be 1, 3. Remember that these brackets and parentheses are sensitive. Okay, so that's your answer for 16. Moving on to question number 17. What is the value of f triple prime of 0? We already have our entire polynomial written down for us, which makes life so much easier. And we're focusing on the third. So we're deriving this 3 times, third derivative. So we're looking for a third degree, which is this. So let's say that f triple prime, remember that this is your Taylor series setup, times x cubed over 3 factorial is equal to negative 8. We're not worried about that x cubed. That's just there to inform us that it's the third degree. We're trying to find out the value, so we are going to ignore the functions, and let's just replace that with 1 over, or let's just replace that with v for value of a function. Okay, v over 3 factorial is equal to negative 8 times 3 factorial. Negative 8 times 3 times 2. Negative 8 times 3 is negative 24. Times 2 is going to be equal to negative 48. This concludes question number 17. 2 more questions. These are the last ones, 18 and 19. All right. And boom. What are all values of p in which this series converges? Let's play with that. Oh, this is so easy. Why? Because we're just trying to, since this is p series, as long as p is greater than 1, it converges. So when p is greater than 1 for p series, it converges. So we're gonna set that what do you call that? The power on the denominator greater than 1. Subtract by 4. Negative 3p is greater than negative 3. Divide both sides by negative 3. Since we're dividing by negative numbers, that inequality is going to flip, so it's going to be p is less than 1. That is your final answer for question number 18. Moving on to question number 19. The sum of an infinite series is. This is a geometric series because we're trying to find sum, and the only formula we have for that is the geometric sum. So it's going to be a over 1 minus r, which is your first term, and this is going to be your rate. Alright, your first term is going to be 2/3 over 1 minus r. Well, we don't exactly have the equation to find the rate, So let's do the second term divided by the first term to find our common ratio. So 1/2 divided by 2/3. Remember that we can use the properties of fractions. That's just going to give us 3/4. 1 minus 3/4, 2/3 over 1/4. Properties of fractions again, 2/3 times 4. Your answer is going to be 8/3. This concludes question number 19, and this concludes part 1 of your series practice test multiple choice part 1. I don't know if we're going to get a part 2 because he normally doesn't put part 1, but if we do get a part 2, I will make a video. So good luck studying, and key tips: know your tests, know your 1 over 1 minus x, e to the x sine and cosine of x, power expansions, know when it diverges or converges, and I think that's pretty much it. Yeah. All right. Thank you.